Subscribe Dr. Sadik Mathematics channel for getting more online videos.
A voltage E power minus at is applied at t is equal to 0. When we are applying voltage, friends? When t is equal to 0 to a circuit containing inductance L and resistance R, then find the current I at any time. Here we are finding here, friends, current. Which circuit, friends? Here this is RL circuit. This is RL circuit. Okay, now how to find the current in the circuit? Today we discuss concept and problems on RL circuit. What, friends? Concept and problems on RL circuit. Let us see the basic concept, friends. What is electrical circuit? Electrical circuit. Electrical circuits consist of energy source, EMF. Okay, friends, it is called electromotive force, and resistance, inductance and capacitance, friends. Once again, friends, the electrical circuit consists EMF, battery, resistance, inductance and capacitance. Okay, now current, we know current is denoted by, friends, current is denoted by, very good, I. It is denoted by I and is defined as dq by dt. I, that is equal to, friends, dq by dt. That means the rate of change in q with respect to time. Once again, friends, I is defined as the rate of change in q with respect to time. Now what is q, friends? What is q? Very good, q is a charge. Q is a charge and it is defined as, how can you define, friends? We know q, that is equal to integral of I dt. What is q, friends? Integral I dt. Integral I dt. Now resistance by capital R, inductance by capital L and capacitance by capital C. The current I passes through three elements, that is through resistance by capital R, inductance by capital L and capacitance by C. Hence, the voltage drop across these components is as follows. Okay, friends, the voltage drops across these components. What are the components here? What are the components here? Resistance, inductance and capacitance. Okay, once again, resistance, inductance and capacitance. Let us see what happens voltage drop across resistance, inductance and capacitance. When voltage drop across resistance is IR, friends. Voltage drop across inductance is L into di by dt. Voltage drop across capacitance is Q by C. Q by C. These three are very important, friends. These three are very important. To solve any problem in electrical circuit, we need these three, friends. ఓకేనా, ఇంకొకసారి అండి, ఈ మూడు అనేవి మనకి చాలా ఇంపార్టెంట్ అండి. ఎందుకంటే ఎలక్ట్రికల్ సర్క్యూట్లో ఏదైనా ప్రాబ్లమ్ సాల్వ్ చేయాలంటే ఈ మూడు మనకి తెలియాలి. ఓకే, వాట్ ఇస్ ఫస్ట్ ఏంటండి? voltage drop across resistance is IR. ఓకే, త్రూ voltage drop across through దేని ద్వారా అండి? రెసిస్టెన్స్ అయితే IR. voltage drop across the inductance is L into di by dt. voltage drop across capacitance is Q by C. Q by C. Now the units for resistance is, we know, everyone knows, friends, ohms. Inductance is Henry. Capacitance is Farad. Current is ampere. Okay, now very important law, friends, very important law. Okay, ఈ లా ద్వారానే మన ఎలక్ట్రికల్ సర్క్యూట్స్ ప్రాబ్లమ్స్ సాల్వ్ చేస్తాము. ఓకే, ఈ లా అనేది మనకు తెలియాలి. సీ కిర్చాఫ్ వోల్టేజ్ లా. వాట్, ఫ్రెండ్స్? కిర్చాఫ్ వోల్టేజ్ లా. In a closed circuit, the algebraic sum of the voltage drop across each component of the circuit is equal to the resultant electromotive force. Okay, resultant electromotive force. That is electromotive force means, friends, it is EMF. Okay, it is based on it is either it is a RL circuit or RC circuit. Based on this, we can define this Kirchhoff law, friends. Okay, let us see. RL circuit. Consider an electrical circuit consisting of resistance R, inductance L. This is, see friends, R is resistance and L is inductance in a series with voltage source or EMF. See friends, previous I told you electromotive force. Okay, so this is here, electromotive force is E as shown in the figure. Okay, this is RL circuit, friends. Okay, this is RL circuit, this is resistance and this is inductance. Okay, this is EMF, electromotive force, friends. Let the current I flowing in the circuit at any time t. Okay, the voltage drop across the resistance is IR and inductance is L into di by dt. We learned previously, friends. Now applying Kirchhoff law, the algebraic sum of the voltage drop across each component of the circuit is equal to the resultant electromotive force. Okay, what is the resultant electromotive force here, friends? E. So what is voltage drop across the components here? IR L into di by dt. What we have done there? Sum. Okay, we are adding these two, friends. We are adding these two. Okay, L into di by dt. See here, L into di by dt. Okay, L into di by dt plus IR. That is equal to capital E, friends. It is electromotive force. Okay, simple, friends. What is RL circuit equation? L into di by dt plus IR, that is equal to E. Okay, in the examination he just asked LR circuit. What is LR circuit equation, friends? L into di by dt plus IR, that is equal to E. Okay అండి, మనకి ఎక్స్టర్నల్ ఎగ్జామ్లో అడిగేది ఈ పైన టాపిక్స్ ఏం అడగడండి. ఓకేనా, కిర్చాఫ్ లా అంటే ఏంటిది, లేకపోతే ఐ అంటే కరెంటా, క్యూ అంటే ఛార్జ్ ఏం అడగడండి. వాడు మళ్ళీ డైరెక్ట్గా ఏమడుగుతాడు, ఆర్ఎల్ సర్క్యూట్ అంటాడు. అంటే ఏమిస్తాడు ఇక్కడ, రెసిస్టెన్స్ ఇస్తాడు, ఇండక్షన్స్ ఇస్తాడండి. ఇండక్షన్ ఇచ్చినప్పుడు ఎలక్ట్రోమోటివ్ ఫోర్స్ ఇస్తాడు. సో ఈ రెండు ఇచ్చినప్పుడు దానికి ఈక్వేషన్ ఏంటిదని మనకు తెలియదు మ్యాథమెటిక్స్లో. ఓకే, వీ హ్యావ్ టు లెర్న్ హియర్ వాట్ ఈస్ ద ఈక్వేషన్, మ్యాథమెటికల్ ఈక్వేషన్. సో బై అప్లయింగ్ కిర్చాఫ్స్ లా, ఓకే, what is the equation? L into di by dt plus IR, that is equal to E. This equation is very very important, friends. This equation is very very important. Okay, see, which is linear equation in I. See friends, linear equation in I. Now based on this I, we have two types, friends, two case series here. First one is invariant source. Invariant source means this E is constant. Okay, invariant source means this E is constant, like 10, 100, 200. Or variant source, that means variant source means function of t. This is very very important, friends. These two types of problems we are solving. Okay అండి, ఇంకొకసారి అండి, ఈ అనేది టూ టైప్స్లో ఉంటుందండి. ఫస్ట్ ఇది ఇన్వేరియంట్ సోర్స్ అంటున్నారు దాన్ని, అంటే ఈ అనేది కాన్స్టెంట్గా ఉంటుంది, అంటే 100, 200 అలా ఉంటుంది. వేరియంట్ ఆఫ్ సోర్స్ అంటే ఫంక్షన్ ఆఫ్ టీ, అంటే ఇక్కడ ఎలా ఉంటుంది అంటే here like e power minus at sin omega t cos omega t ఇలా ఉంటుందండి. ఓకేనా. once again, in RL circuit voltage drops across resistance is IR, inductance is L into di by dt. By Kirchhoff's law, what is equation? L into di by dt plus IR, that is equal to E. This is very very important, friends. This is very very important. Okay, now let us see one problem on electrical circuit. A voltage capital E power minus at is applied at t is equal to 0 to a circuit containing inductance L and a resistance capital R. Okay, which type of circuit, friends? Here this is LR circuit. See here, we have L and we have R here, friends. Then what he says, find the current I, okay, at any time. We are finding here current, friends, I. See, let us see the solution. This is RL circuit. This is RL circuit, friends. What is the equation? What is the equation, friends? Voltage drop across inductance is L into di by dt plus across the R is IR, that is equal to E. This is basic definition, friends. Okay, this is basic definition. Now, what is given data here? What is given? Capital E, that is equal to, okay, this capital E, that is equal to, given capital E e power minus at, okay, e power minus at. Rest of R and L are common, friends. It is as right as it is. Okay, now I divide with L here, friends. First divide with L. Divide with capital L. We get Chapman. Tell me, friends, here di by dt plus R is constant, friends, here. So, write R by L into I, that is equal to, what is E? E power minus at. So, E power minus at. We are dividing with L, friends. So, divided by L. So, this is 2. Which is, come on, tell me, friends, which is linear equation. Okay, which is linear equation. We know linear equation form, friends. What is linear equation form here? What is linear equation form? dy by dx plus py, that is equal to q, friends. Here p comma q are constants or function of x. Okay, function of x. Now, see, friends, R by L is constant. Okay, here we have t, friends. Why we have t here? See here, di by dt, so that we have t, friends. If you observe here, we have independent variable is x, so that we get here function of x here. Okay, that is the difference, friends. Now, what is the solution of this linear equation, friends? First, we are finding here integrating factor. What is integrating factor? E power integral p dx. Okay, what is solution here? What is solution? Y into, okay, integrating factor into, that is equal to integral q into integrating factor into dx plus c. Okay, this is the solution, friends. This is the solution. Okay, now what is solution here? Come on, tell me, what is solution here? Okay, here we have y, friends. In place of y we have I. Integrating factor is common, that is equal to integral q is common, again integrating factor is common. Here we have dx, friends, dx. Now we have here dt, okay, dt plus c. This is the solution form, friends. Solution form. Now, how can you find integrating factor here? How can you find integrating factor? E power integral p dt, friends, p dt. Okay, what is p? R by L. Okay, right here, next line, next page. P is equal to R by L, q, that is equal to, I think, E by L, e power minus 8, I think, say, let us see. Okay, E by L here, E by L, e power minus 80. Okay. Now, what is integrating factor? Integrating factor, e power integral p dt, that is equal to e power integral, what is p? R by L into dt, that is equal to e power, R by L is constant, friends. So, R by L into integral of dt is t. Integral of dt is t. So, what is solution? What is solution? I into integrating factor. Okay. right, I into integrating factor. What is integrating factor? E power r by L into t, that is equal to integral of q. What is q? E by L e power minus at into integrating factor. Integrating factor is e power r by L into t into dt plus c, that is equal to e by L is constant, so write outside integral of, this is like a power m into a power n, so a power m plus n, so e power bases are same here, add these two, we get here, taking common t friends, t, then we get r by L minus a into t into dt plus c, that is equal to e by L. What is the integral of e power ax friends? E power ax by a. What friends? E power ax by a. So e power r by L minus a into t, integration friends, come on, tell me everybody, e power r by L minus a into t by come on, tell me friends, r by L minus a. Okay, in place of a we have here r by L minus a, okay, plus c, that is equal to e by L e power r by L, I want to multiply friends here, t by multiply with t, so e r by L into t into e power minus a t divided by, I want to find LCM here, we get LCM is L, so r minus a L by L plus c. See friends, here L cancel here, okay, L cancel. Now I divide with e power r by L into t friends, okay, I divide with e power r by L into t. So here also we have e power r by L into t, so these two are cancelled. Finally we get here I that is equal to e by r minus al, e by r minus al, I think here e power minus at plus c into, we divide with here e power minus, generally we get here c by e power r by L into t, so that we get here e power minus r by L into t friends, okay, taking in the numerator, so that we get this value. So initially there is no current friends in the circuit, so I of 0 that is equal to 0, okay, I of 0 that is equal to 0. So I am substituting here, that means I of t, so I of t friends, so that means I of 0 means t value is 0, so I of 0 that is equal to e by, see friends, here I have doubt here, this is the L friends, r minus al, so this is L friends, not t, L. Right. R minus al il e power 0, okay, e power 0 minus a into 0 we get e power 0 plus c into here also we get e power 0. We know I of 0 value is 0, so this value is 0, that is equal to e power 0 is 1, e power 0 is 1, so finally we get here e by r minus al into plus C. That implies, what is C value here? You transpose the right hand side or left hand side, we get here minus E by R minus AL, R minus AL. So this is, I think, 3 friends, 3. Substitute in 3, we get I that is equal to, see friends, here E by R minus AL, here also we have E by R minus AL, friends, taking common, E by R minus AL, okay, into, we get here e power minus AT plus, okay, C value is taking common here, we get here minus, friends, here minus so we get e power minus R by L into T, which is the required solution of given problem, friends, okay, which is the required solution of given problem. Once again, friends, he given a problem like this, e power minus 80 voltage, okay, e into e power minus 80. So I substitute here e into e power minus 80, okay. I observe here this is LR circuit. I observation ikkada it is LR circuit ani. So LR circuit equation rasanu, e value sub chesanu, okay. I substitute e value and divide with L here. Now I observe this is linear equation. What, friends? Linear equation. We know linear equation solution, y into integrating factor, that is equal integral of q into integrating factor into dx plus c. Now I compare these two, I write solution for this equation, friends, okay. నేను ఏం చేశాను ఇక్కడ ఈ రెండింటిని కంపేర్ చేసి దీనికి సొల్యూషన్ రాశానండి. సో ఈ ఈక్వేషన్లో y ఉంది, నాకు ఇక్కడ ఏముందండి, ఇక్కడ I ఉంది. సో I write I. Integrating factor is common, that is equal integral of q is common, integrating factor common. Here I have dx, friends, now here I have dt. So I write here dt plus c. Now integrating factor is here we have integral p dx. Now we have integral p dt, okay, t. First I find here integrating factor e power r by l into t, and then I write solution, okay. I evaluate this integration and simplify, and this is very important, friends. This is chala important, and that I of 0 is equal to 0. I apply this condition to each and every problem in electrical circuit. ఇంకొకసారి అండి, ఈ I of 0 is equal to 0 అని ప్రతి ప్రాబ్లంలోనే మనం సబ్స్టిట్యూట్ చేయాలి కంపల్సరీగా. దీనివల్ల మనకి యూజ్ ఏంటంటే, వాట్ ఈస్ ద యూజ్ ఆఫ్ దిస్? వీఆర్ ఫైండింగ్ హియర్ C value, okay. We substitute C value here, then we get the current flow in the circuit at any time t, okay. Hope you understand. If you have any doubt or any problem, please comment in the comment box. Thank you for watching this video. Jai Hind.